So we are beginning chapter 9, and this is our first day, notes 9.1, and we're looking at what we call quadratic graphs and their properties. Please make sure if I'm going too quickly that you pause the video. Make sure you get everything written down. There is a lot of information, and I've got 15 minutes to get it covered. So here we go. Can I graph a quadratic function in the form of y equals ax squared? Let's start with what is a quadratic equation. What is the general formula? It is y equals ax squared plus bx plus c. So that is your general quadratic equation, okay? The equations we're going to look at today aren't going to have the bx and the c. It's still considered a quadratic. Let's go on to the next next question here. What does the graph of a quadratic equation look like? Every quadratic equation that we're going to graph here that's in this form is either going to look, we call it a parabola first of all, that's the name of it. It's called a parabola, and it's either going to look like a U or it's going to look like an arch. Okay, so these are just kind of the basics and the properties of quadratic equations. We're going to jump into specifics here in a minute. What are the special parts of my quadratic equation? We've got some very special parts of it. The first special part that I want to identify is this point right here. Okay, I kind of call it my turning point. It's where it's the bottom of the U, or it's going to be the top of the arch. Okay, and that point is actually called our vertex. So this is our vertex, very important. And it will always be, we'll talk about this in a second, it will always be on what we call our axis of symmetry. So we'll always be on our axis of symmetry. I'll talk about that in a minute. It will also always be what we call our, in this example, it's a minimum value, meaning it's the lowest point on the graph. So it's either going to be a minimum value. If it's a U, it's going to be that minimum value. If it's an arch, it will be the highest point, which we would call our maximum value. So that is all identifying this vertex. The vertex can tell us a lot. So the next thing that we haven't talked about yet, I brought it up, was called the axis of symmetry. And it is a line, and I've hashed it out there, I've highlighted it in yellow. This would be our axis of symmetry. Okay, so I always abbreviate my axis of symmetry as the AOS, just so you know for further down the road. If we're talking about the axis of symmetry, and it is a, let's put in parentheses, it is a line. What does symmetry mean, or symmetrical? It means the same. Look at that line. It divides that parabola right down the middle, where if we were to fold it like a piece of paper, it would line up. They would match up. Okay, let's go ahead and look at our next slide. A lot on these notes and all very important, so please make sure you get it written down. We know that our quadratic equation is going to be in the form of y equals ax squared plus bx plus c. And our goal was to be able to graph one today when it's just y equals ax squared. That's it. So on our next slide here, we're gonna talk about how do we graph a quadratic in the form of ax squared. Well, I'm going to tell you, if you have any quadratics in the form of y equals ax squared, your vertex will always be 0, 0. Something to kind of make note of. And so we're literally just going to make a table. Okay? You'll notice that I've already put my vertex in the table and I skipped a couple spots. And you're going to see why here. We want to pick one x value on each side of that 0. So I'm going to go with a -1 and a positive 1. And I want you to see what happens. Because we're exactly 1 away on both sides of my vertex for the x, look at what happens here. If I put a negative 1 into my equation and I do my math, negative 1 in parentheses squared, that means negative 1 times negative 1, which is positive 1, times 2 is just going to be 2. So we can put a 2 there. But look what happens if I change that to a positive 1. If I put this in as a positive 1, and I square it, 1 times 1 is 1, times 2 is just 2. We get the same thing. Remember symmetrical? It's going to line up on both sides. So we went 1 away from our vertex. Now let's go ahead and go 2 away. What's 2 below 0? We would be at negative 2. And 2 directly above 0 would be at positive 2. Let's put those values in. So if we put negative 2 in, we know that negative 2 squared, so that would be negative 2 times negative 2, is positive 4. 4 times 2 is 8. What do you think is going to happen if I put the positive in? You got it. We're going to get the same thing. Remember, it's kind of a mirror image. Our vertex is going to always be on that axis of symmetry. And let's go ahead and graph it. So I'm going to put my ordered pair at 0, 0. That is my vertex. That's my turning point here. I'm going to go over to negative 1, and I'm going to go up 2. I'm going to go over to positive 1 and up 2. I'm going to go over to negative 2 and up 8. I'm going to go over to positive 2 and up 8. And here you can see that this example is going to create a parabola. We could identify that our vertex here is going to be a minimum value. It's the smallest one. We have a U shape, so we have a minimum value. And that's it. So to summarize, how are we going to graph these? Well, if we're in the form of y equals ax squared, 0, 0 is your vertex. We're just going to make a table. Let's go to the next slide. So on this slide, what I really want to identify is the A value can tell us a lot. Okay, the A value can tell us all kinds of things. So we're going to identify if A is positive or if A is negative. What's going to happen? And we're just looking at the A. I'm not even looking at what the A is. I don't care if it's a 5 or a 75. Just if it's positive or negative. And I want to go to the next slide and then we'll come back to this. So if A is positive, it's going to be a U, pointing to the positives. That's how I always think of it. If A is negative, we're going to be pointing to the negatives. So if A is positive, our vertex is always going to be a minimum. And if A is negative, our vertex is always going to be a maximum. And the last thing that I want to look at is what if A is bigger than 1? I'm not looking now if it's positive or negative. I don't care about that. If A is bigger than 1, what happens? And if A is between 1 and 0, so like a half is between 1 and 0. Let's look and see what happens there. Identify if A is greater than 1, it's actually going to be more of a thinner parabola. And if it's between, it's going to be a wider parabola. So this is an intro to our quadratics. So here I have all kinds of graphs that I've actually done for you. So if we take a look at this, let's look at where our A is positive. So we have A is positive here. We have A is a positive here. Just looking at A. Remember, A is in front of my x squared. We have A is positive here. Talk to me about what you noticed with those graphs. They are all U's. You are exactly right. Let's look at the negatives when A is negative. We have A is negative here, and A is negative here. Okay, where is my A? Let me go ahead and make sure we can see this. This is A, it's a negative. This is A, it's the coefficient of the x squared. Okay, and when we look back at our positives, this is A, and that would be A for our positives. So what do we know? We know that if A is positive, we're going to have a U. If A is negative, we're going to have an arch. So it's one way of checking your answer before or right when you get done. If you have the wrong parabola shape, then you know you did something wrong. So again, it doesn't matter if it's positive or negative. Negative 2. So that 2 is bigger than 1. So this is bigger than 1. Okay, let's look at the next one. We're just identifying. This is between 0 and 1. Three would be bigger. .75, that would be between. And the negative 2/3. 2/3 is 0.6 repeated. That would be between. So look at the bigger ones. We have 2 of those. Right here and right here. How are those, do you think, and it might be hard to see on here, how are those different than the between 0 and 1? Do you notice anything? Well, what I would like for you to notice is that they're a little thinner. Okay, they're not as wide. You'll notice the one right above this gets a little wider. Okay,